Yeah, I'm recording, so don't say anything you don't want on YouTube forever.
Oh, I subscribed to his YouTube last night. I'm not even joking, yo.
Huh? What's a YouTube video? I think it's just my name. Like and subscribe. It's after this afternoon. I post every day. I do. All right, so 7.1, we're adding and subtracting polynomials. Today's lesson is stuff we've done before. We're just going to kind of make sure that we're all on the same page because we need to know how to do it moving forward. So we're just going to do read this little box here. So to add polynomials, you have to combine like terms and make sure it's in standard form. Standard form meaning that it's your exponents. The largest one is the one that is farthest to the left when you're writing it, and they go down as you go. So if we're trying to find the sum between these two polynomials, 10y plus 8 plus negative 4y plus 12, we're combining like terms. The parentheses, in addition, when we're adding polynomials, aren't, they're just there. So we can drop them off. So that's what I'm going to do. I'm just going to rewrite this without parentheses. So plus minus 4y plus 12. And then if you ever have like a plus minus, these two things together, you can change that just to a subtraction sign. So that's what we'll do. 10y plus 8 minus 4y plus 12. And then we combine like terms. A like term, a constant, and a constant is a like term. Coefficients with the same variable are like terms. So these two y's, this 10y, this minus 4y are like terms. When I combine like terms, I like to underline so I know what I'm adding together. So I underline these two together. I have 6y, because we take 10 minus 4. And then we take our other terms, our constant terms, 8 and 12. That will give us plus 20. So we combine two polynomials to get one single binomial that's first degree with the leading coefficient of 6. So that's why we kind of, on the day I was out, you did that combining like terms worksheet because we're doing the same thing here. All right. B, we're adding two polynomials again, so I'm just going to drop off our parentheses. So we have 4x squared minus 10x minus 12 plus minus 2x squared minus 6x plus 22. So again, same thing. Plus minus can turn into a subtraction sign. So we can have 4x squared minus 10x minus 12 minus 2x squared minus 6x plus 22. So now when we have a lot of terms, this is kind of when your underlining thing is more helpful because it keeps all kind of your pieces together. So if I know I have to add my largest degree term, if I want to use standard form, so I'm going to add this x squared term to this x squared term. So 4x squared plus negative 2x squared will give us 2x squared. My next highest degree term is this x term here. So you have a minus 10x and a minus 6x. So this will be a minus 16x. And then we have our two constant terms. Your constants are always going to be your caboose of your polynomial. So take negative 12 plus 22, and you get out a positive 10. So plus 10. So this will be a trinomial that is second degree with a leading coefficient of 2. All right. Next one, C. We don't have a plus minus here, so we're just dropping out the parentheses and we can go from there. We could say 8z minus 2z cubed minus 6 plus 4z cubed minus 10z squared plus 16. So you're going to have to go on a little scavenger hunt through your polynomial to find your highest degree terms. So look at what power is the biggest. We have to the power of 3 and to the power of 3. That's our highest degree term, so I'm going to combine those first. So if I take negative 2z to the third plus 4z to the third, I would get 2z to the third. My next highest term would be the squared term. I have nothing to combine it with though. This is the only z squared term. So if I can't combine it with anything, I'm just writing it into my final answer. 10z squared. Same thing for 8z. I don't have any other z terms to combine this with, so I'm just putting it into my final polynomial. So I'm going to go plus 8z. And then finally, adding my constants together, negative 6 and positive 16 will give you, all of us, not just me, positive 10. So here's your final answer. This would be we call it a quartic. That's what the word for 4 terms, a quartic polynomial, degree 3 with a leading coefficient of 2. All right, so last example, we're going to do example D. I guess the last example of adding, not of the whole note sheet. So we have v plus 3 plus 3v squared plus 6 plus 3v cubed plus 6v squared plus 9v. So even if we're adding 3 polynomials, we're still just combining like terms. So v plus 3 plus 3v squared plus 6 plus 3v cubed plus 6v squared plus 9v. So I'm just dropping out the parentheses. What would be my highest term? What do I want to start with? 3v cubed, because that's my largest power and there's nothing else I can combine that with. So it just goes by itself. We have 2 squared terms. We have 3v squared and 6v squared. So we could say plus 9v squared. And then we have 2v terms. This is a 1v. And we have a 9v at the back. So together we have 10v's in total. So we say plus 10v. And then our constant terms, we have 3 and 6. So this is plus 9. So this is our final polynomial. We'd call this, again, it's 4 terms, so we call it a quartic. It is degree 3, and it has a leading coefficient of 3. So let's add it. You did this on, like I said before, the combining like terms worksheet. If you can do the combining like terms worksheet, you can do this. The combining like terms worksheet was a lot more difficult because it had distribution in there. This is stuff we reviewed at the beginning of the year, and now it's coming back. Subtracting polynomials, there's kind of one little hiccup we got to always account for. Is to subtract polynomials, we're always going to have to distribute the -1 into the second polynomial. Then we can combine like terms and check that it's in standard form. So distributing the negative 1 into the second polynomial, what that means is in front of this second parentheses here, we could really have this be a negative 1. And that negative 1 is going to be distributed to each term inside of parentheses. This kind of holds the integrity of our subtraction that's happening. And really, all multiplying by a negative 1 does is change the sign. So if something's positive, it's going to make it negative and vice versa. So our first polynomial doesn't change. We have 2d minus 18. And then we distribute the negative 1 to the 6d. So we have minus 6d. And then negative 1 times negative 2, that's plus 2. And then we combine like terms. Boom and boom. And then these are like terms here. So this will be negative 4d minus 16. So this is a binomial that is first degree, that has a leading coefficient of negative 4. Example B, we're going to start out the same way. Distribute the negative that's in front of that first parentheses. Also just think of it as you're changing the sign of each term as you go. So writing out my first polynomial, nothing changes. So this is plus 6y squared plus 12y plus 18. Combine like terms, looking for my highest degree term so I can get it in standard form, would be my y squareds. I have 2y squared and 6y squared, so that would give me 8y squareds in total. I have two y terms. I have negative 8 and positive 12. So when I add those two together, I would get out a positive 4y. And then always your caboose of your polynomial, your constants. So we have an 18 and then another 18. So those added together are 36. So plus 36. So this is a trinomial that's degree 2 with a leading coefficient of 8. All right. That's all for the front page. Flip to the back. If you feel confident enough to go ahead and do the back ones on your own while I'm talking, feel free to do that. Giving you permission. Otherwise, just keep following along with me, writing down what I write down. And if you do finish after doing it on your own, you can check back with what I have on the board to see if you did it right. All right, example C on the back page, distributing a negative, that means you're changing each term's sign in the second polynomial. So you have minus 12r cubed, minus 3r squared, minus 21r. So my highest degree term is my negative 12r to the third. But that does not have a like term that I can combine with. So that's just going in the front. No combining there. Also for my second highest term, that r squared term, the minus 3r squared, doesn't have any like terms. So say minus 3r squared. Do a quick look through, find your next highest degree term. That would be anything that's degree 1, which is we have a r and an r. Those are both first degree, so you can combine those. So negative 3 minus 21, that's negative 24r. And then we just have a constant in the back, that minus 30. Again, having it in standard form is important. If you don't write in standard form, it's wrong. I'm going to be picky about that. I'm not normally a picky person, but I'm going to be picky about standard form. Yeah, recording. All right. D, we're going to take by multiplying the negative 1 into the parentheses. 7y squared minus 3y plus 12y plus 18. Our like terms are in the middle here. So we have 7y squared. This would be plus 9y plus 18 as our final answer. So this is a trinomial degree 2 with a leading coefficient of 7. All right, word problem time. The word problem, it's talking about streaming services. So a premium subscription to a streaming service. X weeks is represented by the polynomial 12x plus 284. The basic subscription is represented by 24x plus 568. It says write a polynomial that represents the total number of, and then I copy and pasted, and I didn't change that part. We're not talking about the fitness center. We're talking about subscriptions. But in the homework, you're talking about subscriptions. You're talking about the fitness center subscription. So this problem is just like the word problem on your homework. So when you do see it, don't panic, because it's exactly the same. All right. So to find the total number of subscriptions, that would be like taking the premium subscriptions, or the number of your premium subscriptions, plus the number of basic subscriptions you have. So we would take the 12x plus 284 plus 24x plus 568. And we do the same thing. Just combine like terms. We take 12 and 24x, we get 36x. And then we add 8 and 4 together. So you get, would that be 258? I don't know why I read that backwards. 852.